Good day, everyone. You are welcome to ChemExcel Academy Chemistry Clinic tutorial. Based on the last practical work that was carried out here, we were able to arrive at the average titer value, which is also known as average volume of acid used, to be 25.65 cm3. Alright. Good day, everyone. Welcome to ChemExcel Academy Chemistry tutorial. Based on the last practical work that was done the other time, we arrived at the average titer value, which is 25.65 cm3. That's the average volume of acid used. Of course, that's our fee, which we are going to use in subsequent calculations. Here is a tip of questions which may likely come out during the forthcoming examination. The first question, we are going to treat series of questions, but here is a typical example of questions that you may likely encounter. One, for the first one that you are going to consider, is solution A contains X gram per dm cube of H2SO4. Solution B is a solution of sodium hydroxide containing 0.025 mole of the alkali in 250 cm3 of solution. Then we have equation of reaction here. Equation of reaction, which is tetrasulfate 6 acid reacting with sodium hydroxide to give us sodium tetraoxosulfate 6 and water. Then we have to tabulate our bread readings and obtain the average volume of acid used. Of course, that is what has been done here. Then, what are the other questions that we may likely encounter? They are these. From your resource and information provided, calculate the concentration of A mole per dm cube. The second question, number 2, number of hydrogen ion in 1 dm cube of solution A. The third question, the value of X. The fourth question, which are going to be volume of solution A that would react with 64 grams of sodium hydroxide. Thank you. I would like you to follow my channel, like, share, and subscribe. Possibly, I will be expecting your comments as this aspect will continue. Thank you. Alright, we can now begin to solve questions one after the other. Having understood what we are likely going to encounter, the first thing to do is to write the equation of reaction. Solution. The first thing to do is to have the equation of reaction. Equation of reaction. Equation of the reaction. Equation of the reaction. Of course, we are going to rewrite this equation again. Why do we need to do that? So that it can serve as a guide for us. So in order to prevent us from flipping through our questions again and again. Of course, this will be needed, especially the number of moles of acid and the numbers of moles of base. Now, we will rewrite the equation of reaction as this: H2SO4 aqueous plus sodium hydroxide plus 2 mole of sodium hydroxide solution to produce Na2SO4 aqueous plus H2O plus 2 moles of water, 2 moles of H2O. After all, this kind of equation reminds us of what we call neutralization reaction. Of course, this is what you have been taught in acid-base titration, while we are doing acid, base, and salt in SS1D. Okay? From there, we move to the fourth question, which says we should calculate the concentration of A in mole per dm cube. Alright, to calculate the concentration of A in mole per dm cube, we now say to calculate concentration of A in mole per dm cube. Mole per dm cube. We need to calculate the concentration of A in mole per dm cube. We need to calculate or determine the concentration of B in mole per dm cube first, since the concentration in gram per dm cube of A was not given. Assuming it was given, it should have been concentration of A in mole per dm cube equals to concentration of A in gram per dm cube over molar mass of A. We can determine the molar mass of A, but we cannot determine the concentration in gram per dm cube of solution A. That's the reason why we can't go for that. We rather go for that of concentration in mole per dm cube of B first. Therefore, we say 0.025 mole of NaOH mole of NaOH dissolved in 250 cl of solution. Therefore, X of NaOH we dissolve in 1000 cm of solution. That means we are going to make X the subject of the formula. If that is done, we now have X to be equals to 0.025 times 1000 divided by 250. And finally, we are going to have our answer to be 0.n cube. Of course, that is the value to obtain for the concentration of B in mole, concentration of our base, that is concentration of sodium hydroxide in mole per dm cube. Or we can say number of mole should be equals to concentration down in mole per dm cube multiplied by volume in cm cube divided by 1000. If we do that, we can also have our number of mole to be equals to concentration. What is the number of mole from the question? Quickly check here. 0.025 mole. 0.025 mole to be equals to concentration. Of course, that's what we are looking for. Concentration in mole per dm cube multiplied by volume given is 250 cm cube over 1000. Having obtained this, then Okay, from there we can have concentration in mole per dm cube. Concentration in mole per dm cube should be equals to 0.025 mole multiplied by 1000 divided by 250, and that's going to 0.02, and that's going to give us 0.100 mole per dm cube. Either way, now we can also, therefore, concentration of B in mole per dm cube is equals to 0.100 mole per dm. This will be our CB. This will be our CB. Now, having done that, we can now move to the formula for us to calculate the concentration of A mole per dm cube. You can say to calculate the concentration in mole per dm cube, to obtain the concentration of A in mole per dm cube. Then we have formula. We have the formula. CA VA over CB VB is equals to NA over NB, where our C is the concentration of acid in mole per dm cube. Of course, that's what we are looking for, or what we are to calculate. Our VA is the volume of acid in cm cube, that's the average titer value. Then CB, concentration of base, the value we obtain here. VB, the volume of pipettes, that's the volume of base, the volume of pipettes. And it's always 25.00 cm cube or 20.00 cm cube, depending on the center, because every candidate in the center must use the same pipette or three, because they have to record the volume of pipette given to them at the onset of the table of titration, then the indicator used. They have to record the two. Though there may be no mark for it, but it is expected that students or candidates report that. Okay, the number of mole of acid, that is our Na. We obtain that from the equation of reaction. Of course, from there, the number of mole of acid here is, since there is no any value here, we believe that the coefficient that's supposed to be here will be 1. Of course, that's our Na. For here, you say your Na is 1, whereas our Nb here is 2. And having substituted that, we are going to go. Now, we move down here. We need to substitute our value. We have our Ca, we can say given. Ca, our Ca unknown, Cb, Cb 0.100 mole per dm cube. Our Va, That's our average titer value. That's 25.65 cm cube. What we obtain from the table of titration. Then VB, which is equals to 25.00 cm cube as volume of pipette. NA is 1 from the titration, from the equation of reaction. NB, comma, then NB is given to be 2. Having noticed, just substitute straight away. By the time we do our substitution, we now have CA, of course, unknown, multiplied by CB, 0.100 mole per dm cube, over CB, what's our CB? CAVA, 5.65 cm cube, over CB, 0.100 mole per dm cube, multiplied by VB, 25.00 cm cube, which is equals to NA 1 over NB 2. Having obtained this, we can make CA the subject of the formula. It is compulsory that you show the substitution, especially this aspect. This is compulsory you show it. If you don't show it, you lose your mark, even in spite of what you have presented or ahead. Then you now make CA the subject of the formula. If you make the CA the subject of the formula, what are we going to likely obtain? We now have CA to be equals to 0.100 mole per dm cube multiplied by 25.00 cm cube multiplied by 1 divided by 25.65 cm cube multiplied by 2. Our CA will now be equal to, you multiply what we have over there, equal to 0.0, 3 decimal place, as far as that one is concerned. Divided by 25.65 multiplied by 2, that's going to give us 51.30. 51.30. Then, if you press your calculator, you are going to obtain 0.0487 blah 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 blah, but to 3 significant figure. You leave it at this edge. You leave it at this stage. Mole per dm cube. That's to 3 significant figure. Of course, you may not need to write it there for them. They will have know that that is what you have done. You have done. And I say, therefore, the concentration, because that's what we have been asked to calculate. The concentration of A in mole per dm cube is 0.0487 mole per dm cube. That's going to be our final answer for calculating concentration of A in mole per dm cube. The number of hydrogen ion. You have to determine the number of hydrogen ion in 1 dm cube of solution A. Determine the number of hydrogen ion in 1 dm cube of solution A. For us to obtain that, second question is that we have to calculate the number of hydrogen ion in 1 dm cube of solution A. And that can be done. We say number of hydrogen ion. See number of hydrogen ion. Number of hydrogen ion in 1 dm cube of solution A. Of solution A can be calculated as we have the first thing to do is to obtain the formula for calculating number of mole. We say number of mole. See, number of mole, as we all know, number of mole is equal to concentration in mole per dm cube times volume in dm cube, because they have stated it that is 1 dm cube. Volume in dm cube. What is the concentration of our A? Concentration of our A is 0.0487 mole per dm cube multiplied by volume, which is 1 dm cube. You can see here that per dm cube cancel out dm cube. Then we have mole as the only unit that's going to remain at the end of the day. Then we can also 0.0487 multiplied by 1, and that's going to give us 0.0487. That makes us to get this calculation, which is number of mole that we need to consider while getting this. Okay, we know that we are dealing with an acid which is dibasic in nature. That is H2SO4. H2SO4 can easily get dissociated in water and then give us 2 moles of hydrogen ion with tetrasulfate 6 ion. Now that takes us to this. We have H2SO4 equals forward, backward reaction arrow to give us 2H plus equals plus SO4 2 minus equals 2. Now this is hydrogen ion. This is one mole of tetrasulfate 6 acid dissociate to give us 2 mole of hydrogen ion. Therefore, 0.04 mole of tetrasulfate 6 acid will give us what mole of hydrogen ion. That's what we are going to state here now. We can now say from this equation, from the equation above, we are referring to this equation. From the equation above, 1 mole of H2SO4 equals from the equation above, referring to this equation on the board, 1 mole of H2SO4 produced or liberates in solution in water, liberates 2 moles of hydrogen ion and 1 mole of tetrasulfate 6 ion. Of course, we have been considering the major point of consideration here. The main character here is tetrasulfate 6 acid and 2 moles of hydrogen ion. Now, having understood that, we can now say 1 mole of, from the equation above, referring to this, 1 mole of tetrasulfate 6 acid produced or liberates, produced 2 mole of hydrogen ion. Therefore, 0.0487 mole of tetroxosulfate 6 acid, we produce whatever value you have here, you multiply it by 2, then divide it by 1. We produce 0.0487 mole multiplied by 1 mole divided by multiplied by 2 mole divided by 1 mole. And that answer will be, that is of, don't forget this, of hydrogen ion, because that's what we are considering. Just because there is no more space, I have to just manage it and put it down here. Or let me write it divided by 1. If this is okay, then that will give us, if you can see, mole, we take care of mole here, and then the final unit still remains as mole. Our final answer will now be 0. If you press your calculator, you will have 0.0974 mole of hydrogen ion in aqueous. Don't forget, this meaning of AQ means aqueous. We are telling you the state at which this occurs. Now we can also say number of mole. From here we say number of mole. Say number. Okay. Having obtained this, we can say number of mole. Number of mole. Number of mole is equal to number of hydrogen ion, number of hydrogen ion over Avogadro number, there are different formulas for calculating the number of mole. One is number of mole equals to reacting mass over molar mass. Reacting mass in gram, while molar mass in gram per mole. Another one says number of mole is equals to concentration multiplied by volume in the concentration mole per dmq multiplied by volume in dmq. While another one says number of mole equals to, that is the last one, the last statement that I just said. That is if your volume is given to you in dmq. But if the volume is given to you in centimeter cube, number of mole is equal to concentration in mole per dmq multiplied by volume in cm cube over 1000. And another way of calculating number of mole is number of mole equals to number of particles. That's from SS1 days. You should have been told this. Number of mole equals to number of particles. With that particles, you can bracket it. It can be number of molecules, number of atoms, or number of ions over Avogadro's number. In this case, since we are determining the number of ions, it's going to be number of mole equals to number of hydrogen ion over Avogadro's number. Having understood that, we can now put our number of mole here, which is 0.0974 mole, 974, to be equals to number of hydrogen ion, over 6.0, the one that is given to us in the question, times 10 raised to power 23 per mole. Now, at the end of the day, if you do cross multiply, cross multiply, you now have number of hydrogen ion, number of hydrogen ion, number of hydrogen ion, which is H plus, is equals to 0.0974 mole multiplied by 6.0 times 10 raised to power 23 mole per mole. 10 raised to power 23 per mole. Per mole, we take care of mole. Then our final answer will now be equals to, if you multiply it through the use of your calculator, we are going to have 5.84 times 10 raised to power 22 kilos times 10 raised to power. The next one says value of x. How do we determine the value of x? It's very simple. That value of x simply, now the value of x can be calculated as the value of x can be calculated as we are to find the value of x, and we need to understand, if you check the question given to us, they say x gram per dm cube of H2SO4. In other words, we are to find the concentration gram per dm cube of H2SO4. And since we've already know the concentration mole per dm cube of our acid, that is the H2SO4, we can easily determine the molar mass of H2SO4. First thing is to determine the molar mass of H2SO4. How do we do that? The molar mass of H2SO4, we want to calculate that, which is, say, 1 atomic mass of hydrogen is 1 multiplied by 2 plus sulfur is 32, that's the atomic mass of sulfur, plus oxygen, which happens to be 16 multiplied by 4. And then we have 2 plus 32 plus 16 times 4, that is 64. By the time we sum up all these figures together, or values together, we have 98 gram per mole to be the molar mass of the tetrahydrogen acid. Then we can now come over and say, if we want to calculate the concentration of either acid or base in mole per dm cube, it can be calculated as concentration of solution either A or B in mole per dm cube equals to concentration of A or B in gram per dm cube over molar mass. Therefore, we can make the concentration in gram per dm cube the subject of the formula in this case. Our concentration in gram per dm cube will now be concentration in mole per dm, will now be concentration in gram per dm cube of X to be equal to concentration of A, solution A in mole per dm cube multiplied by the molar mass. Then we can now say concentration of A in gram per dm cube is equal to concentration of solution A in mole per dm cube, mole per dm cube in mole dmK multiplied by molar mass of H2SO4. Therefore, we can now have our final answer to be equal to 0.0 0.0487 mole per dmQ multiplied by 98 gram per mole. If that is done, we are going to have an answer to be 4.77 approximately to 2 decimal place, 4.77 gram per dmQ. You can say therefore the value of x is equals to 4.77 gram per dmQ. We have obtained the value of x, of course, which we are going to calculate. The last question under this aspect, under this part, we are to determine the volume of solution A that would react with 64 grams of sodium hydroxide. This is between A and solution A and solution B. Is our point of concern.
Yeah.
Say the volume of solution A, volume, that's number 4, the volume of solution A, volume of solution A that would react with 64 grams of sodium hydroxide can be calculated as the molar mass of sodium hydroxide. If you look at that, the atomic mass of sodium is always given to be 23. The atomic mass of oxygen is always given to be 16. While the atomic mass of hydrogen is always given to be 1. Therefore, we can now 23. We have 23 plus 16 plus 1, and that is going to give us 40 grams per mole. 40 grams per mole. Now, having known that, we say number of mole of sodium hydroxide. Take the number of mole of sodium hydroxide. Say number of mole of sodium hydroxide. Number of mole of sodium hydroxide, as we already can recollect or recall, that number of mole equals to reacting mass over molar mass. Therefore, we can now say number of mole of sodium hydroxide equals to reacting mass of sodium hydroxide in gram over molar mass of sodium hydroxide in gram per mole. Very important. We must recollect this in the course of our calculation. Now, what's the reacting mass from the question? you have been given the mass of sodium hydroxide in the question. That's going to be 64 gram over molar mass of sodium hydroxide that we just calculated, and that is 40 gram per mole. As usual, gram takes care of gram, then we have our value to be 1.6 mole. That's 1.6 mole of sodium hydroxide. Now, that will take us to that calculation, that equation of reaction. From the equation that was written the other time, if you remember, we say it is 1 mole of tetrasulfate 6 acid that reacted with 2 mole of sodium hydroxide. If you can recollect from the equation of reaction, you can now say from the equation, maybe I should write the equation. You can have H2SO4. Having known that, you quickly do the balancing of equation. Oxygen is altogether at this side 5, altogether at this side is 5. Okay, now we talk about hydrogen. Hydrogen is 3 at this side, hydrogen is 2 at this side. That means we need to come over here and put the coefficient of 2, which have to be even number. 2 times 2, we have 4. Hydrogen is 4 here, hydrogen is 3 here, then we put 2 here. Then that makes hydrogen to be 4 at the side, hydrogen to be 4 at the product side too. Of course, sodium becomes balanced, and every other thing becomes balanced as a result of that. Now, this is 1 mole of tetrasulfate 6 acid reacting with 2 mole of sodium hydroxide. If 1 mole from the equation above, from this equation, 2 mole of sodium hydroxide reacts with 1 mole of tetrasulfate 6 acid. Therefore, 1.6 mole of sodium hydroxide will now react with how many mole of H2SO4? This is 1.6. This is very important. Now, you can see equation above from the equation above, 2 mole of sodium hydroxide reacted with 1 mole of H2SO4. Therefore, 1.6 mole of NEOH will react with that will be 1.6. I put the answer to be 1.6 mole multiplied by 1 mole divided by 2 mole of H2SO4. That's going to give us 1.6 divided by 2. Mole, take care of mole. 1.6 divided by 2. Of course, that's going to give us 0.8 mole of H2SO4. Okay, 0.8 mole of H2SO4. And if you remember, they say number of mole concentration in mole per dm cube, multiplied by volume, in either a CM cube or 1000. Now number of mole equals to 0.8 mole to be equals to 0.8 mole equals to concentration was acid equipment 0.0487 multiplied by volume. The volume is what we are looking for. Volume is CM. Everything divided by 1000. If we do a cross multiply, we are going to have the subject of the formula here, the volume. We now have volume to be equal to 0.8 mole, 0.8 multiplied by 1000 divided by 0.0487. Okay, at the end of the day, we are going to have a value to be 16.42.
Okay.
Or is it that we have it in CM cube in this form, or we have 16 points, just like dividing this by 1000 to take it to the n cube, 16.43 GM cube. That's our final answer. Mind you, this calculation is based on the average titer value which will be given to you by your instructor in your various center. That does not mean it should be the same thing with what you see in this video. There may be variations, or it may be almost the same. But mind you, whatever you are giving your center is what you should use anytime you are doing your calculation. Whatever you are given as a average titer value in your center, that is what you should try and work around in order to obtain correct and accurate values at the end of the day. Don't forget it. Very, very important. Alright, having known this, I would like you to once again like this video, share it, subscribe to it, and then I will be expecting your comment. Thank you.